close encounters with stars can change the structure of our planetary system and potentially doom Earth or other planets. There's an interesting contradiction about our galaxy. It's both full of stars and strangely empty. The Milky Way is bustling with hundreds of billions of stars, along with vast clouds of gas and dust. However, there's a lot of space between them. The nearest star to the Sun is over 4 light-years away, which is tens of trillions of kilometers. This distance is immense, making it hard to comprehend. It's almost unfathomable that it takes tens of thousands of years for space probes to reach the closest star. There are also denser areas, like some star clusters that contain thousands of stars in a small space, making the center of the galaxy a crowded region. But here, in the outskirts of the galaxy, stars are spaced further apart, allowing plenty of room as they orbit in the Milky Way. However, given enough time, some stars will enter our personal zone. About 80,000 years ago, a small red dwarf named Scholz's star passed just 0.85 light-years from the Sun. In the future, around 1.3 million years from now, a star named Gliese 710 will pass much closer, at just 0.17 light-years away. While those distances may seem vast on a human scale, they are mere moments in galactic time. The Sun and its collection of planets, asteroids, and comets have existed for over 4.5 billion years. During this immense period, it's almost certain that the Sun has had several close encounters with other stars. The question remains, what effects do such encounters have on the solar system? The Sun is surrounded by a vast halo of trillions of icy bodies known as the Oort cloud. While none of these objects can be seen individually with current equipment, occasionally, one of them enters the inner solar system and appears as a long-period comet in our sky. Estimates of the size of the Oort cloud vary, but it may extend more than a light-year from the Sun. If a star passes through this region, its gravitational force can disturb these icy masses, sending hundreds or even thousands of them toward the Sun, some of which might collide with the inner planets. Some researchers have even speculated that such a passage could lead to a mass extinction. A new study published in the Astrophysical Journal Letters reveals that the passage of the star Scholz likely couldn't cause devastating effects. This star is too low mass and moves too quickly to effectively disturb the Oort cloud and rain death upon our world. However, over time, other stars might actually cause trouble, creating chaos in the distant regions of the outer solar system. Fortunately, we probably have thousands of millennia to prepare ourselves. Nonetheless, such celestial passages can have other concerning consequences. Many astronomers have pondered the long-term stability of the planets in the solar system, as they gravitationally affect each other over millions and billions of years. The early solar system faced severe instabilities, but recently these effects have become much subtler. Strangely, Mercury, the innermost planet, is significantly affected by these dynamics. The physics of this phenomenon is complex, but, in summary, small changes in Neptune's orbit, the planet most influenced by stellar passages, propagate inward through the solar system. Neptune affects Uranus, which impacts Saturn. Saturn influences Jupiter, and Jupiter, being the largest planet, influences all others. As a result, the orbits of Mercury and Jupiter can lock into a resonance, meaning their orbital periods are simple ratios of one another. When this happens, Mercury receives an extra push, like a child who adds momentum to a swing by kicking at the right time. For decades, it has been known that these effects can alter the eccentricity of Mercury's orbit, sometimes stretching it into an elongated shape. If Mercury's orbit becomes too stretched, it may fall into the Sun or get close enough to Venus to be ejected from the solar system. Mars could also suffer a similar fate, as it, like Mercury, has a more elliptical orbit compared to Earth or Venus and may experience significant changes in its orbital shape over a long time frame. In the past, most simulations assumed the solar system was isolated, with no other stars intruding. However, we now know this isn't the case, and to accurately understand the evolution of the solar system, we must consider the effects of these stellar intrusions.